Okay, guys, sorry this is a little bit late. This is Pre-Calc PS Week 3. We begin off determining whether or not it's a function, and remember that if each input has exactly one output, then we can determine that it is a function. So what we're going to do kind of depends on the how we're presented the relation or the function. So here we're given a set of ordered pairs, so all we're going to do is look for repeated x values. Okay, I don't see any repeated x values, so sounds good to me. Really, when we're given an ordered pair, that's enough information. Now you notice if it is a function, find the domain and range. Well, for the domain, you're just going to list out each individual element for x, -3, -2, so on and so forth. And then for the range, you're going to list out every single element for y, 9, 4, 1, so on and so forth. Up next, we got x is an irrational number, so remember how to read this. This is the set of x, or set of all points x comma 1 such that x is an irrational number. If we think about this graphically, the output is always 1. So that means that any irrational number is going to follow along this horizontal line, and there are no two irrational numbers that will output us the same value. Or sorry, it's not going to output us two values because we only have one possible output, which is 1. And so yes, this is a function. In terms of writing the domain and range, don't worry about it too much. The range should be pretty easy because that's the only possible output. Now for the domain, it depends on how you want to classify this. I would say x is irrational. If you want to be a little mathy, then you can see x is an element of p. Most textbooks talk about p as the set of irrational numbers, just like z represents the set of integers. All right, very similar for these two. I'm not too concerned about the domain, and let's talk about it, I guess. So for if this is a function or not, I input a value and then I square that value. Yeah, that's a function. That's the function f of x equals x squared. We input an x value and we output x squared. So yes, this is a function. The domain for this is going to be -infinity to +infinity. And then the range for this function is going to be 0 all the way up to infinity, because when I square a number, the smallest number I can actually get is 0 inclusive. Now this other one says that I'm going to have x squared comma x. Well, it was chill when it was x comma x squared because I took a value and squared it. But here, to go from x squared to x, I have to square root x squared, which gives me a plus or minus x. So no, this one is not a function because I'll have two outputs. Find the following in simplest form. Okay, so the first one is just evaluate the function at 2. And so we get a value of 7. The next one, we're going to input x plus 2 everywhere we see an x. 2, x plus 2 squared minus x plus 2 with parentheses plus 1. Distribute that negative. Expand x plus 2. Distribute that 2. Combine my like terms. Looks like 2x squared plus 3x and then plus 7. Okay, so there's that one. 2x squared plus 3x plus 7. Wow, sorry, I made a quick mistake there. So yeah, it should be 2x squared. That should be 4x in the middle because it's 2 times 2x and then plus 4, which is actually going to change this to 2x squared plus 7x plus 7. My apologies there. Okay, then the next one, we're just going to add these two quantities together to get f of 2 plus f of x plus 2. So that becomes 2x squared plus 7x plus 14. And then the last one is literally just multiply everything by 2. And that's going to give me 4x squared. 4x squared minus 2x plus 2. Okay, so composition of functions, very similar substitution. All right, now we're going to talk about domain. So with domain, when there's an even index, whatever is inside the radical has to be greater than or equal to 0. So we just solve this inequality. And then we write it in interval notation. So everything, including 3 over 2 up to infinity, will work for us there. Next up, we'll have two things to consider. The first one is, just like before, greater than or equal to 0, which says that x has to be greater than or equal to 1. Whoops, that's bracket. Bracket 1 to infinity. Then the second one, well, we got to worry about division by 0. If this denominator equals 0, then we can not have that. So I'm going to add square root of x minus 1 because we can't divide by 0. That gives me this. I'll square both sides. That gives me this, and then I will solve for x. Okay, so x equals 3 makes this one 0. X equals 5. Okay, sorry. It's been a really long day for me. I did so much math today. My rhythm takes a little off. Okay, x equals 5, so that means I'm going to go from -1 up to 5. I cannot include 5. I'll put my union between it, and I'll go from 5 up to infinity. And then this last one, you might have went like this, but don't remember that you need to exclude that value because now you have a hole in your graph. Discontinuity. Okay, piecewise function, depending on where we are, that's the domain we'll use. So I look for -10. Does -10 fit here, here, or here? Well, -10 is less than or equal to -10, so I'm going to use this function, t squared minus 5t. If I look at the next one, f of 0, 0 is right here. 0 is greater than or equal to -2, so I'm going to use this function. And then finally on the last one, -2 also uses that last function because it's equal to, and so I'm just going to simply evaluate them. When you evaluate those, you will get the following. You get 150, you get 0, and you get -8/7. Okay, population, modeled, input 0. If I input 0 here, it's obvious the population is going to be 0. If I input 10, that's going to give me 150 times 10 all over 10 plus 15, which ends up simplifying to... actually don't have the value, but this is the population in 1610. So whatever this value simplifies to is what you get. 1,500 divided by 15. Okay, good. Sorry, divided by 25, not 15, gives me 60. And then the domain for this, I can include 0. You just saw me do it. And it depends on how you want to consider it. You could put it up to infinity, but if you want to really be a stickler to today, then you should put it up to whatever ends up being 2023 minus 1,600. So 423 it looks like. And I'm going to keep it exclusive because I haven't actually talked about that date just yet. We don't have the end of 2023 yet. Okay, now we got some composition of functions. This is where you're going to take f of x. We'll start with f of x. And everywhere that we see an x in f of x, we're going to now put g of x. So I have g of x cubed plus g of x plus 2 squared plus 1. Well, now I can actually input what g of x is. It's x plus 1. X plus 1 there. Don't forget to add that 2 before you square it. And then we go. Remember Pascal's triangle? We'll use these rows. 1, 3, 3, 1. I got 1x cubed plus 3x squared plus 3x plus 1 for this first distribution. Then the next one is now x plus 3 squared. That's x squared plus 6x plus 9. And then the last one's just plus 1. So when we input all this stuff, we combine our like terms, we end up with x cubed plus 4x squared plus 9x plus 11. F plus g of x is simply just take these two things and add them together. When you do that, you get x cubed plus x squared plus 5x plus 6. On this last one, I didn't really require you to do the long division, but you can actually long divide this if you'd like to. I'll accept this answer. Difference quotient. All right, that's f of x plus h minus f of x all over h. This is the quantity that you're computing. That's called the difference quotient. So I have f of x already. It's 2x squared plus x. I don't have f of x plus h. So let's figure that out. I'm going to put an x plus h everywhere that I see an x. Okay, f of x plus h equal to 2. X squared plus 2xh plus h squared plus x plus h. That ends up being 2x squared plus 4xh plus 2h squared plus x plus h. Okay, there's my f of x plus h expanded, so I'm going to toss that in right there. 2x squared plus 4xh plus 2h squared plus x plus h. I'm going to subtract off f of x, which is 2x squared plus x. I'm going to make sure to use parentheses here. And then I'm going to subtract 2x squared minus 2x squared, x minus x. I'm left with 4xh plus 2h squared plus h all over h. And then you should recognize that I can actually reduce all these h's to get 4x plus 2h plus 1. This is one of the more challenging questions on here. We'll be working with a difference quotient in the future, so don't worry too much if you're struggling. It's a lot of arithmetic. And then finally, you guys did this one on your RLK last week. That is f of x equal to 4 over square root x minus 13. And the domain for this one is 0 to infinity because I have that radical. Hope you guys enjoyed the P set.